Thank you very much. Welcome to our event today. We will be talking about applying MLOps for SKU rationalization, focused specifically within the consumer packaged good and retailer industry. My name is Deb Lee. I'm joined today by my colleague Ben Dunmire. We're both senior consultants at Thorogood with extensive experience delivering MLOps and data science initiatives at large manufacturers and retailers in the consumer packaged goods industry. We're excited to be here today. In terms of what we're going to cover, I'm going to start us off with a quick introduction to Thorogood, covering who we are, what we do. I'm then going to speak a bit to SKU rationalization itself and why it's becoming more important now than ever. I'm then going to cover a bit of how MLOps can specifically address some of the key challenges that we're seeing our customers and the wider industry in general facing in terms of getting their ML models into production at scale. Ben's then going to actually take you through a case study where he covers the business problem, the technical approach, and some of the models that we took, and then as well as some of the impact on how we're seeing our customers benefit from this type of implementation overall, and then we will wrap up. Thorogood is an independent specialist consulting firm. We strictly focus on data and analytics, keeping in mind a keen business focus on every project that we do. We have global offices out of London, Philadelphia, Boston, Singapore, Sao Paulo, and Bangalore. And while we do offer a range of services across strategy, solutions, technical implementation, and services, the primary work that we do is within that application design and development space. We're technology agnostic, so we partner with a number of different technologies that are relevant for the data and AI space. So we don't just partner with Microsoft or just with AWS or Databricks. We use the best tools that fit the needs of our customers to get the job done. I'm now going to speak a bit to SKU rationalization. So what are we talking about when we say SKU rationalization? Sometimes also known as optimization, reduction, or simplification. This is a common process that we are seeing across all of our CPG and retail customers, wherein they're interested to identify and determine whether or not an item should be kept in an upcoming shelf reset. So you want to take into account the costs of manufacturing, the cost of goods, stocking, and selling the item. So you're really looking to optimize your inventory to help both suppliers and retailers focus in on the best items for the consumer. A recent McKinsey survey paper, I would check it out if you haven't seen it yet, has really highlighted that COVID-19's impact has made the consumer preferences within the CPG space, even within the same category, fluctuate quite a bit. So things are still changing quite rapidly. There's a lot of unexpected consumer behavior. So as you're thinking about how do you optimize your inventory in your portfolio, you want to make sure that you're focusing on being responsive to consumer trends, that you're building better resilience into your supply chain from a disruption perspective, maybe that you're more aware of where potential new product category opportunities could be. So a big one that we saw last year was hand sanitizer, for example. And you want to make sure that your innovation pipeline is scaled up enough to meet the changing consumer behavior. And then always you're going to want to look to reduce the costs, sort of everything in the face of unpredictable demand. Before I get into MLOps for SKU rationalization, I'm going to talk a bit more around what we're seeing in the world today in terms of ML and AI at scale. So a study that MIT Sloan did with BCG found that 71% of respondents felt they understood how AI would change the way their business generates value, but only 11% reported actually seeing significant benefit. 66% of organizations either increased or did not change their AI investments since the onset of COVID-19. Worldwide spending on AI is expected to double in 4 years to 110 billion in 2024. However, when we come back to this survey, how can there be such a discrepancy between people understanding and seeing the value that ML and AI can provide for them, but then such a low number of individuals saying that they're actually able to see these benefits? There's clearly something going on, challenges that organizations are facing to actually deliver on the value and get their models into production so people can start using them. to really harness the value of those investments. That is where MLOps comes in. So I'm going to talk a little bit around data science and MLOps approaches and how this has really helped some of our customers address their key challenges. Why are people struggling? Based off of what we're seeing across projects and helping our customers develop data science and MLOps frameworks for how they do these tested alongside some of our implementation projects, I'm going to bubble up some of the key challenges that we've been seeing, and then I'll get into how MLOps can address them. So scalability. It's hard to sort of scale a model potentially to other countries or markets or channels or retailers, depending on how it's built. So that could be because of the tooling or even the way that the code is built out. And then parallelization. So if you're trying to run 1,000 models every day, well, 20,000 models every single day, and you're not using a tool that natively supports being able to scale across nodes on a cluster, it's going to be quite challenging to scale. Governance, so getting alignment from senior leadership as to what MLOps and data science teams should be doing and what their responsibilities are. And then also duplication of assets. So we do see a lot of times sort of similar data science models and products popping up in different markets, having invested tons of resources to get to a very similar, let's say, time series forecast. So I think this is a big challenge for many organizations. Reliability, so really getting that trust from the users, getting users to trust that the model is giving them a better replacement for probably what was a manual human process that they were doing before, as well as timely incident and issue resolution. So even once you have a model in production, if you can't reliably debug when an error is thrown or there's exception handling happening, you're going to start to lose that trust and you're not going to be perceived to be reliable. Resiliency. So you want to have reproducibility and auditability of all of your assets. So of the code, of the models, and your data sets that you're using. This is a huge challenge, not even just in data science applications, but I would say more generally in all sort of data-driven initiatives. But then library versioning, making sure that they're security compliant, they're not sending out your data from an open source perspective to the rest of the world. And then accuracy. So how do you make sure that you're maintaining and monitoring your accuracy of a model once it's in production? And how do you ensure that that accuracy doesn't dip as the world continues to change? And then making sure that you're building things in a system wherein the tools that you're using allow you to more easily integrate model enhancements so that you can continuously improve that accuracy of that model. So this is where MLOps comes in. So it's going to help you address all of those challenges. I'm not going to steal too much of Ben's thunder, so he'll touch on a couple more during his section. But I'm going to give an overview of what are we talking about from an MLOps perspective. So you're going to start out by defining your business needs, that MVP or that POC. So in our case, we want to simplify our product portfolio from the lens of that sales volume, market growth, margin, and supply chain costs. We also want to understand how the innovation is performing. So are there potential opportunities and growing segments in the market that maybe we're not picking up on that a model could pick up on? Then, once you're happy and you've defined your MVP or your POC, that's when you'll start experimenting. So this will involve cleansing, normalizing, doing that feature engineering, data engineering, and then rapid prototyping. So you're going to be testing out different types of libraries, maybe classification combined with clustering, combined with regression. Maybe you switch them around. But really the output is that you get a trained model that's suitable for productionizing. So once it's been vetted and you're happy to move that model to production, you're then going to want to make sure that you're truly productionizing all of the CI/CD components needed for that model to train and score at scale. So data engineering, data science, data visualization. You then may need to refactor a bit depending on the tool that was used to experiment, depending on the extent to which the code was modularized. And you want to make sure that you have that automated testing and monitoring capability built in as you go to production. And then once you get into production, it's important to keep monitoring and improving your models over time. So you'll want to monitor for drift and potential performance issues around model decay. You also will want to continue gathering feedback from your users around the model as well. So are there things that we didn't consider when we were building out that initial POC that could be quite valuable to test to see if they add some more value to the model? That's where this cycle starts to come in, where you then start to go back and you define what are some of the enhancements, how do we experiment, and then you push them into the production system, hence the continuous integration and continuous deployment nature of MLOps. So in terms of what I'm going to be showing you guys today and what Ben will cover a bit later, just wanted to give an overview of our overall technical flow for the SKU rationalization setup. We're going to be using a combination of Databricks and Microsoft tools today, but that being said, you could also use tools such as SageMaker for some of the functionalities here. We're going to be doing some data ingestion and copy into our data lake, data engineering using Databricks, Data Factory. We'll have the model training and evaluation happening using Databricks and AMLS. We'll have model serving and deployment in AMLS as well. This is a batch use case. And then we'll be using a number of tools, and I'm going to show you some of these to pick up on some of those monitoring capabilities, such as application insights, Azure Machine Learning Services, and Power BI. And then finally, model consumption. So I'll also give a view as to how the end user would be looking at some of the results of these models and help them better inform what they decide to keep or not keep on the shelf. We will have Data Factory and Azure Machine Learning Services doing all of our job orchestration, as well as Azure DevOps for our CI/CD pipeline automation. I am going to now switch gears and give a quick technical demo that will highlight how some of the tools that we're using for MLOps will address some of these traditional challenges that I just talked about in production data science applications. So the first one that I'm going to cover here is within the Azure Machine Learning Studio portal. So what you are seeing on my screen right now is just the home screen. So once you log in to Azure Machine Learning, you'll come here. It'll see some of the recent stuff that you've been working on. But what I would like to highlight specifically, especially around some of those challenges for auditability, resilience, and reproducibility, are the dataset functionality here. So if I go to datasets, you can see all of your registered datasets within Azure Machine Learning. So this registration would have been done as a pipeline step overall for me. But what's cool about this is if you go into a data set, let's say I got new data next week and I ran the pipeline to automatically register it. Now I can go in and start to track and go back in time and see the profiles of my data sets and how they're changing over time. So I don't need to dig through a bunch of old things to try to find what I was working with last month or potentially the version of the model that I had last month. The other thing that I want to call out that I'm pretty excited about is this dataset monitors feature, which is in preview right now. So you can actually, once you have a dataset registered, you can actually go in and you can create an automated drift tracking alert. So choose the time period over which you'd like to track the drift, give it a name. You can select all the features for which this alert is applicable. You need a compute cluster defined or created already to use this. You can specify the frequency, the latency, and then specify your email address here, as well as the threshold for which the alert is defined. So this is pretty exciting because this is giving people an automated way in which you can actually start to really track that drift. The other component that I would like to show here, so if you go into experiments, this is where data scientists can start tracking their experiments. So you can see here I have a classification experiment. I can go in, I can see all of the runs, I can see metrics on those runs. If there are multiple steps in that experiment, I can go in, I can see which step was run when. I can even go in and then look at the metrics for my experiment as well to see, okay, for each of these steps, what are some of the metrics that I'm getting from my model for all of these? So this is all done natively within the UI. All you need to do is just add a few lines of code to start logging these things out into Azure Machine Learning. The final component I'm going to mention as well is the model registry here. So you can start registering your models and tracking the versions on them. So similar to the data sets, if you have you're registering many different models over time, and let's say you're getting new ones every single week, the model registry is the place where you're going to track all those models. The final screen I'm going to show is a Power BI workbook, which is really going to surface the sort of some of the impact and the value that users will be able to get out of this. So I have a couple of different screens because we're using a number of different types of modeling components here around classification, clustering, and time series. But if you come in here, you can see that in terms of what my model is giving me for this latest training run, the percentage of discontinued SKUs that it's recommending make up about almost 2% of sales overall for the time period, but they make up about 21% of the number of items that I have on the shelf. So you can start to get a sense that, okay, there definitely are some opportunities here for me to clean up. You can also see how the SKUs are distributed. So it looks like cluster 6 seems to be one where there are quite a few where it's recommending to discontinue them. I can also start to drill into specific items as well. So I've sorted this based off of sales because I'm interested to see, of the big selling items, which ones is it saying to discontinue? So if I look at this one maybe, and the trend over time, I can start to get a sense of why the model might be telling me I should discontinue this SKU. I can see a year ago its sales were significantly higher. They've plummeted a bit, and now most recently they haven't gotten back up to those levels where they were at before. Maybe I look at a different one and I can see a similar story, a bit of a recovery, but not enough for the model to say that you should keep this item. I'm now going to hand it back over to Ben, and he is going to take you guys through a bit more of a customer case study.
Excellent. Thank you, Deb. So I'll pick up there and, like Deb mentioned, get into talking about a case study and talk about a bit of the approach we took and some of the results from it. So I'll restate a few things here that Deb had set up and give it a bit more of the structure around what we had done. So we've talked about the problem SKU rationalization, high inventory costs, effort and complexity in managing a supply chain, and brands managing their product mix. And what we really like to do is run this rationalization on a recurring basis, whether that's to rescore or to fully retrain based on market shifts. So how do we do that? That's the problem. Like with anything, it's important to make some assumptions, some logical assumptions to give us parameters for what we're doing. You can see a few examples here. So things like segmenting the data by something like category and retailer, because we want to be comparing apples to apples in most cases. What's how comfortable or confident we are in the length of the forecast. So a forecast 10 years out, probably don't really trust that too much, but 6 months, I think that's something we can reliably trust. A number of features that we know are important that matter to retailers, to suppliers that you'd obviously want to consider, and a few other things here. So we define those assumptions. That's the basis for how we're approaching it. And then to really make this usable, to get buy-in from field users and to make it practical, you have to have the business intelligence and knowledge injected into it. So a few examples here, a couple of them being with innovation, you'd likely want to handle that a bit differently or flag that. It won't be very sensible to recommend removing a product that's been distributed for a few weeks or a month or something like that. And in other cases, we know that sizes will often ship between like 10 to 12 ounce or 24 to 22 ounce, and often that's not that noticeable, but it necessitates a new SKU number. We'd want to be able to kind of merge those products together, so we're thinking of them consistently. And a few other ideas here. So really, to make this usable and to have it trusted and practical, you have to have the kind of domain premise and apply that sort of knowledge to any sort of solution. And that you could say that about anything, but particularly here when it's recommending removing a product from your mix, it's a pretty significant thing. It's obviously hard to go back from that. So to talk about the technical approach, and then I'll jump to some code to show this in a live version. We'll talk about the flow of data and the thought process. So starting with our data collection and engineering, use an external and internal mock data set, and created some calculations, did some enrichment, and then, like I mentioned, narrowed it down to a single category and segmented our data in a reasonable way. The first thing we've done is applied clustering to the data, and it's really aimed at adding an additional attribution to a SKU to give us kind of a bit more information about it. So clustering based on size, so actual size of the product, and then price, which is a pretty common technique. And And really, like I said, they're meant to provide another piece of information. Deb was showing the ways in which we can visualize it. We can also see that clusters that are growing, their share or their size, ones that are shrinking, ones that are staying stagnant. That's added information in our decision making. Next, we're similarly adding additional information about our SKUs and what we expect from them. So creating a time series demand forecast to look at volume. And we can use this in a number of ways. We can look at the forecast of an entire cluster, which again helps to see, is this a growing cluster? This is a growing kind of set of products that we should invest in, we should stay in. Is it dying off? Is it are we not losing much? But then it also gives us a bit more information. If we can kind of have some confidence in what's going to happen 6 months out, 8 months out, it does help us influence, should we keep a product, should we drop it? And then lastly, and really where we're making the recommendation, is a number of classification algorithms that are used to basically tell us, yes, keep it, or no, drop that product. So we used historical resets. So it's a good way to kind of use training material of what's in the past been dropped, because that's real influence. But ultimately looking at some key features. So I mentioned these before. We know margin matters. We know total volume matters. Velocity is quite important. And comparing against the rest of the sets, and ultimately tune this and try a number of different techniques that I'll run through to make a recommendation by SKU, by retailer. And Deb touched on this. I'll talk about it a little bit. The way of our MLOps activities, and then our front end reporting. So how are we sharing this with people? How are we managing it over time? We might need to retrain as market shifts. We introduce innovation. We might just need to rescore every couple of months, and it's great to be able to do that in a couple of hours as opposed to weeks that it might take users to do it. And of course, this is cyclical, like Deb was talking about. As we're rescoring or retraining, as we're identifying other features or other data sets, which are quite important, as we're pushing to other channels or categories. So a few principles we followed: parallelism. So when you're defining forecast for hundreds of thousands of SKUs, we'd like to do them in parallel. We Spark to do that. Having options in features, so building up that data engineering pipeline, so we have lots of different options to choose from in terms of measures and categorical values. Parameterization, so that's going to help us scale out as we roll out to other retailers, other channels, other suppliers. I mentioned being able to rescore and retrain at will, so we want to build that in. That's automation and flexibility. So I mentioned business intelligence, so that's both the reporting lens and the sharing of information, but also the kind of business knowledge and domain knowledge to input that into the model, so we're being practical and realistic. And then modularity, which is important thing that particularly now in modularizing the different components, so we can interchange them. And Deb mentioned this. I'll just put it up quick and then move on from it. But the tools that we used, so again, use the Azure stack here, largely Databricks and Azure Machine Learning. But really, we have lots of flexibility. It could be AWS or GCP. We could interchange even within the Azure tools. So it's great to have flexibility because it gives us options to use best in breed tools, to use what we're familiar with or what's available to us. But it does demand that you have some consistency, and Deb talked about standardization and practice patterns that it's important to define. So if I move on here, let me jump to another screen and I'll show a bit of a demonstration here briefly. And to set this up, this is a case study, again, based on some customer experience and some R&D for taking the role of a supplier for one of their largest categories. So look first here at a number of functions. So I talked about modularizing things. So rather than having or cluster codes sparsed out in multiple different notebooks, for example, it's defined in a function, and that function can be referenced 1 time or 1,000 times. And you can see here it gives us that consistency and that modularity, that ability to switch out. So again, a few using k-means clustering. You can see a couple of parameters that we've set here to execute that model, and then some logic to determine, based on the silhouette score, what number of clusters for a given segment of data makes the most sense. So we look at the notebook that actually runs this. So we, again, do some setup. And here's where we're connecting to our Azure Machine Learning resource. And Deb showed it a little bit. If I have time here, I'll flip to it. But here we're more or less connecting to it and being able to log information, which is quite useful. We can use that for monitoring, tracking, and all sorts of other good stuff. Some data preparation. So I'll scroll down, and you can see here we're executing all of those functions to kind of prepare the data. And you can see it's not necessarily pretty in the Databricks screen here, but the output. So for each segment of data, so it's likely a combination of a retailer category to give it an apples to apples comparison. We can see this score for the number of clusters through a range here, so 3 to 8, and of course do more, 3 to 7 maybe. So we can see based on the silhouette score, what number of clusters for a given set of data is most logical. So pretty interesting. Runs in a few minutes here for a good chunk of the category. And I'll quickly scroll down. This is just some management. And we can see in outputs, this is just for one of the data sets, one of the segments. You can see 3 clusters. Again, low price, low volume, higher price, higher volume, bigger sized, and lower price. And then up here, we have a bit distributed, more higher priced products. So again, this is useful. We can use these categories to then influence our later models. So if we look at our time series, again, same sort of thing. We're using functions to define the model. I think this one's pretty interesting because it's using a user-defined function. If I scroll down to it here, so again, profit. So Facebook profit expects a pandas data frame, but then we lose our ability to parallelize and get a great performance gain of Spark. So you can see there's a user-defined function here to effectively manage that and be able to parallelize pandas, which is pretty cool. And again, bit of engineering code executing the model, which is up here, and then we can see the output. And this is one product or maybe a couple of products, so we can see the relevance of the forecast. You can see predicted out a couple of months. I think we're showing maybe 4 or 5 months here. So again, this is pretty valuable information. These data points are useful. We can use those as we can use trend. We can use the perception of these movements to indicate growth or lack of growth. Okay. And then the last one I'll show here, and then we'll look to wrap up our session, is the classification notebook. So again, same sort of activity, logging in machine learning, or Azure machine learning, I should say, and we're writing in a number of functions, and again, building this in another place and referencing it. You can see we've developed a number of different classification models. So logistic regression, scroll down here, decision tree, and random forest. So a couple different models that we're able to run all of them and test them out, choose the best one, or the one we think is most accurate. So again, a little bit of preparation, run some of our functions. We'll create vectors of our data set and our key features. So a number of normalized features here that we're then inputting to the classification, executing for each of the models. So you can see here running for each of the 3 models. You can see the outputs here. So you can see our accuracy, which is quite high. Probably need to look at overfitting here, so that's something we'll have to pick up. And then a function here to determine the best model, so looking at the accuracy. So in this case, it looks like the random forest was most accurate. You can see that here. And then I think, and Deb showed this earlier, but if I scroll down here, a few lines of code here with Azure, using the Azure ML SDK. We can log this on Azure Machine Learning. So Deb had shown the screen where it had the different scores, and we're doing that here with Deb said, a few lines of code. And the ultimate output, we're dating a prediction and an actual, so we can see how we feel about the results. So I'm kind of just running out of time here, so I'll jump back to the slides and look to wrap up here. I'll summarize the kind of impact or what to take away from this. So Deb showed an example of the accuracy, which is kind of pretty interesting. We're able to apply different classification methods to it. In terms of the results, and Deb showed this on the front end, but we've got an increase in average retailer margin and velocity, picking a few measures, some very important ones to us and to the organization. So this way we can kind of quantify, what's this kind of minimized set of SKUs, what value they're providing. I think some of the biggest points here, the ability to take away this need to crunch numbers and do analyses from the business for something that, this takes about 2 hours to run all of this stuff for, a pretty decent data set. The ability to run that in 2 hours, which, normally would take a couple of weeks for a group of analysts to do is pretty impactful. Well, we can do it for a number of items, a big category across a number of retailers in a little bit of time in the cheap parallelization. And we're ultimately resilient and be able to rescore and retrain as needed. It's not, once a year that we, double down and do this. It's, once a week, every day, every hour, if we really want to. And then just a collection of the models which we talked through, and I won't talk through these, but we're thinking about what we want to do next. So I talked about overfitting. How can we pull this to other categories and other channels? So how might this look if we run it for e-commerce, where it's a bit different mindset and maybe different impacts from COVID, for example. So lots of other stuff we can keep doing. So I'll wrap up quick here and let people go. Just to talk a bit about some of our experiences, so beyond SKU rationalization, but with CPG, manufacturers, and retailers as well. You can see some of the organizations we work with in the middle, and a number of the projects and activities that we see coming up quite a bit right now and are actively working on. So trade promotions, big one, using unstructured data. So looking at maybe ESG data, or there's so much data out there. I mentioned e-commerce and omni-channel, and then kind of setting MLOps governance frameworks and data science governance frameworks is pretty active right now. And I won't go through each of these, but it's kind of a kind of listing of our different activities that we do, kind of building off the previous slide, but really where we're seeing kind of a lot of activity across our customers, where we see people investing and going back to kind of Deb's opening about, people realizing, this stuff's important, data science, machine learning, AI, but doesn't really see what we're getting to it. We're getting value out of it, and really where we're looking to help. So exploration, so taking hypotheses and proving or disproving them. MLOps and DevOps, which Deb talked about quite a bit. So setting up centers of excellence, defining standards, implementing solutions, industrializing solutions, so scaling up, building them. Architectures, so talked a bit about that in across Azure, AWS, and Google. Democratizing data, so we talked about how can we kind of play into our users, how can we make something that's trustworthy, understandable. It's one of the toughest things from data science is if something's unbearably complicated, and even if it's right on, it's perfect, if people can't understand it, they're not going to use it, not going to trust it. Empowerment, so things like training when we're looking at skill profiles, particularly now when we're trying to scale up these abilities and drive developer organizations. Multi-cloud and flexibility. So we talked about the different cloud providers and ways in which you build towards that, and then strategies. So again, a lot here, but certainly do reach out to us if you have any questions, things you're working on. So second to last slide here, upcoming events, and then a number of things on our website that are relevant. So building quite a bit out around MLOps, CPG, everything. Particularly draw your attention to the Data and AI Summit hosted by Databricks, where Deb herself will be running a session, which is really exciting for Deb and for us. So definitely subscribe to that. And beyond Deb's session, lots of sessions, which should be really interesting into this month. So thank you very much for attending today. Our contact details are on the screen. So again, feel free to get in touch. As with the day, may the 4th be with you. Thank you very much.